Hi everyone, welcome back to my YouTube channel. My name is Inoy from ADDIS University, and also I am a Southern Hemisphere University software engineering student. For now, I am going to help answer this problem. If you are new for educational YouTube, make sure to subscribe our YouTube channel in order to access every engineering problem solution. As you can see, this problem is all about the graphical representation of motion. We can represent the motions of a particles by using different methods. From this method, the graphical representation of motion is very important in order to understand the concept of vectors and in order to visualize our concept. So we can use the concept of the time derivative of a vector and solve this problem. The vector may be acceleration, displacement, or distance or positions. So here we can give the acceleration versus time graph from time t 0 up to 9 from one phase, and from t9 up to 14 on the other phase. Then we can construct the velocity versus time graph and the distance versus time graph by using the concept of the time derivative of vectors. First, from this acceleration versus time graph, which has two phases, which means from t is equal to 0 up to t equals to 9, which is acceleration is equal to under radical 36 t, and from t up 9 up to 14, acceleration is equal to 40 minus 18 t. We can use the time derivative of this and calculate the velocity versus time graph. In order to construct velocity versus time graph and distance versus time graph, we must know about this concept, which means acceleration is the first derivative of velocity with respect to time, or the second derivative of position with respect to time, and the velocity is the first derivative of distance or with respect to time. It is a very important formula in order to draw this acceleration velocity versus time graph and distance versus time graph. A is represent acceleration, B represent velocity, and T also represent time. So here we are given acceleration as square is equals to 30t. From this, A is equals to 6 radical t, since A is equals to under radical 36. By using the calculator, we can take under radical 36, we can get 6, and 6 times under radical t, which is acceleration, is equals to 6 under radical t. We can find the velocity from here, since acceleration is equals to first derivative of velocity dv by dt. We can substitute in the place of a, and which is equals 6 times under radical t. From this, we can integrate both sides and calculate velocity. By integrating both sides, v equals to 6 times 2 over 3, which means t the power of 1 over 2 plus 1, which is 2 over 3, times 6 under radical t cube plus c1, which is our constant. Then we can find our constant c1 from a time t is equals to 0, v0 is equals to 0, since at t is equals to 0, we have acceleration is equals to 0, distance is equals to 0, and v0 is equals to 0. So 0 equal to, at time it is 0, 0 times this number is also 0, plus c1, 0 is equals to 0 plus c1, c1 is equals to 0. So from a time 0, we can get c1 is equals to 0, and v is equals to under radical 4 times under radical t cube for 0 less than t less than 9. At time t is equals to 9, we can substitute the value of 9 and the value 9 in the place of t, and we can get at time 108, which means we can draw the graph here in the place from t 0 up to 14. At t is equals to 0, we can get 0. At t is equals to 9, we can get 180, and at t is equals to 14, you can get the velocity by using these equations. So acceleration is equals to 40 minus 18, and acceleration is the first derivative of velocity. We can substitute this and we can integrate both sides. After integrating both sides, we can get 40 square over 2 minus 18t plus c2 is constant, and which is at a time t we can get 108, and 100 we can substitute the value and we can get c2 is 108 simply after simplifying this problem. From time 9 up to 4, at time 9 is equals to 108, at a time t is equals to 14, we will get the value by substituting t equals to 40 in the place of t square, and we'll get 248. After this, we can simply draw the graph, which means at time t equals to 0, we'll get v is equals to 0, which is at time